Jamb repeated question number 4. The question reads, what is the oxidation number of sulfur in hydrogen tetrazosulfate? Very common in Jamb UTME. You must see this question in your Jamb UTME 2026. I am giving you 99% assurance that you are going to see the calculation of oxidation number in your Jamb UTME 2026. You are going to encounter 2-3 questions from oxidation number. They might ask you, what is the IUPAC nomenclature of the above compound or of the compound? They might ask you, what is the name of the compound? They might ask you, what is the oxidation number of so elements in this compound? Jamb can ask you the question in various ways, but what's important is learning how to calculate oxidation number, which is very easy. It's a free mark, it's a bonus mark. So learn this and get your free mark. Among the option, A is -2, B is 0, C is +4, D is +6. Oftentimes, we cram oxidation number, okay? We cram oxidation numbers of compounds because we read them in textbooks. We don't even know how to calculate oxidation number. How if you encounter a question where you are asked to find the oxidation number or the IUPAC nomenclature of a complex salt? You don't have the oxidation number by heart. What are you going to do? You are going to forfeit the question. So let me show you how to easily calculate oxidation number. Let's understand what oxidation number is first of all. Oxidation number. Oxidation number is the charge an atom appears to have when electrons in a compound are assigned based on a rule. Just know that oxidation number is the charge an element or the atom of an element appears to have when electrons in the compound are assigned based on rule. So there is a certain rules used to calculate this oxidation number, and that's what we are going to learn as we carry on with this lecture. What is the use of oxidation number? It is used to identify oxidation, to identify reduction and redox agents in reactions. So you use oxidation number to identify if a reaction is an oxidation reaction, if the reaction is a reduction reaction, or to identify the redox agents. Which of the agents lost electron during the reaction? Which gained electron? Oxidation number helps us ascertain these. Oxidation number also helps us name chemical compounds. Okay, that's another additional use of oxidation number. Let's quickly look at the rules of calculating oxidation number. Key rules for determining oxidation number. The first rule, which is number 1, free element equals 0. So you have to understand basic equation for you to calculate oxidation number. So it is always equal to 0. That's the simple meaning of this. It is always equal to 0. After writing out your equation, you must put it equal to 0. It must be equal to 0. Okay, equal to 0. Sodium on a solid state, oxygen in a gaseous state, chlorine in a gaseous state, sulfur, all the elements in their free state is equal to 0. Number 2, under the rule of determining oxidation number, simple ions equals their charge. Simple ions equals their charge. For example, sodium ion, it has how many ion? 1 ion, and that's the charge. Remember, oxidation number is the amount of charge an atom appears to have. So that charge, simple ion, the charge available is the charge, okay? So the ion is the charge. So sodium here exists as 1 ion, that's plus. So you have to know their ions, okay? The amount of ions available for you to know the charge, because you are going to use the charge to calculate the oxidation number. So oxygen ion is 2, the charge is 2, okay? Oxygen, the charge is 2, and so on and so forth. The third rule of calculating or determining oxidation number, oxygen equals -2 usually, okay? So except in peroxide like hydrogen peroxide where oxygen is equal to -1. The charge oxygen is having in this state, this peroxide state, hydrogen peroxide, is -1. But every other state or every other form of oxygen, you are going to calculate the charge using -2, okay? Usually -2. So the rule number 4, hydrogen equals to +1, okay? It's only 1 plus 1 charge plus 1. Remember, hydrogen is the first element, and hydrogen is the only non-metal that is positively charged. Hydrogen is the only non-metal that is positively charged, except in metal hydride. For example, sodium hydride, where hydrogen equals -1. So in every other form that you see hydrogen, every other compound, it's +1. It's having the plus, okay? These signs are very, very important and necessary. You have to know the signs that they are coming in. Is it a plus sign or a minus sign? Electronegative element like the non-metals always come with minus, okay, because they are negative, electronegative. Electropositive elements are mainly metals, okay, and they come with plus, okay, they are positively charged. So like I said before, hydrogen is electropositive element, though it's a non-metal, but it's electropositive element. The only exception is the hydride. When it exists as hydride, it's negatively charged, it becomes -1. So you are going to use -1 to calculate it if you are having hydride as the chemical compound. Do not forget the one for oxygen. It exists as -2. Only in the peroxide, the hydrogen peroxide form, where it exists as -1. That's the charge. So the fifth rule of calculating or determining oxidation number is sum of oxidation number equals 0. Like I said before, it must be equal to 0. Basic equation. equal to 0. In a neutral compound, when the compound is neutral, in the normal state, okay, the regular state of the compound is equals to 0. Rule number 6, group patterns. What are the group patterns? The first group pattern is group 1 metals. All the group 1 metals, if you know the periodic table well, all the group 1 metals, just know that all of them are +1 charge. They are having +1 charge. Then all the group 2 metals, all of them are having +2 charge. That's the charge they have. Aluminium, okay, then aluminium is the only one having +3 amongst them. Rule number 7, fluorine is equal to -1. Remember, fluorine is the most electronegative element. Always the most electronegative element. That's fluorine for you. The charge of fluorine is -1. So let's illustrate the rule number 1 to 7 in an actual exam condition. Example 1. What is the oxidation number of sulfur in SO2? What do? We quickly write out our parameters, the given, okay? Sulfur, because we are looking for the oxidation number of sulfur, we are going to represent it as S in the equation. So let's take it as S, okay? The formula for the elements, okay? The symbol or the formula for the elements, S. So take it as S because it's sulfur we are looking for. It's just like S, you are looking for S in mathematics. So here we are looking for sulfur. We are taking it as S. Sum of all oxidation equals 0. Like I said before, sum of all oxidation equals 0 is always equal to 0. Okay, when you are calculating it, it's always equal to 0. Oxygen is equal to -2. That's the charge of oxygen. But remember, here, oxygen is having 2. So this 2, you are going to use it to multiply the charge of the element. So any oxidation number, okay, so any oxidation number that the element is having, you are going to use it to multiply the charge of the element. So if the element is having any oxidation number, you are going to use that oxidation number to multiply the charge. So let's look at it. So S, since we are looking for S, which is sulfur, and sulfur is the first thing there, we are starting with S, okay? So S plus 2. Why is it plus 2? Remember, the oxidation number of oxygen here is 2. And 2 is also known as plus 2. Plus 2 is same thing as 2 in mass. So S plus 2, bracket open, because we are going to multiply it by the charge of the element itself, which is oxygen. How many charge does oxygen have? -2. That is the charge of oxygen. So we are going to multiply. So bracket open, -2, then bracket close. Equal to what? 0. Sum of all oxidation, which is 0. And solving this, we are going to multiply this 2 by -2, which is going to give us S minus 4. 2 times -2 will give you -4. Minus times plus, minus. 2 times 2, 4, which is -4. So S minus 4 equal to 0. So since we have this, we are going to do what? Collect like term. You know how to collect like term in mathematics? Because 4 is a number and S is an alphabet. We are going to move the alphabet to this side and bring 0, that is also a number, to this side, okay? Because it's an alphabet and this one is a number, collecting like terms. So when we move S to this side, S becomes -S, and when we move 0 to this side, 0 becomes -0. So that's what we have here, -0 minus 4 equal to -S. So when we do -0 minus 4, what is it going to give us? -0 minus 4 is what? It's going to give us -4. -0 minus 4 is equal to -4, equal to -S. So since we are looking for S, we are going to bring S. S is going to cross this equal to sign coming to this side, and 4 is going to cross this equal to sign going to this side. So S, remember, minus crosses equal to sign becomes plus. So we have S, which is also plus S, equal to +4. Minus 4 crosses equal to sign, it turns to what? +4. So the oxidation number of sulfur in SO2 is 4. So this compound is called sulfur 4 oxide. Example 2. The question reads, what is the oxidation number of manganese in potassium tetraoxomanganate? Following the normal rule, first of all, we have to write out our parameters. We have to write out the charge. You know we are looking for manganese, the oxidation number of manganese in this compound. So potassium here, we are going to start with the first element. Potassium here is equal to +1. That is the charge. Potassium is an electropositive element. It's a metal, okay? So it's going to have +1. It only have 1 charge, okay? And it's the group 1 metal. So it's the alkali metal having only +1 charge. So that's it. And the next we have here is the manganese. Remember, we are looking for manganese and we are going to represent it with its chemical formula, which is Mn. So the next parameter we have here is oxygen, okay? And the charge of oxygen is -2, apart from the peroxide form where it's having -1. So if it was hydrogen peroxide here, we are going to use -1 here. But every other compound, the charge of oxygen is -2. So the sum of all oxidation equal to 0, the normal equation style. Let's go. Manganese, since we are looking for manganese, Mn, we are going to start with manganese. Manganese, which is Mn, plus, we are continuing with potassium. +1 is having +1, look at it here. +1, +4. The next we are having here is 4. Why is it +4? Remember, the oxidation number of oxygen in this place is +4. 4 is the same thing as +4. So +4, because we want to multiply it by the charge of oxygen, we are going to open bracket -2. bracket close, equal to sum of all oxidation number, which is 0, normal equation style. So when we solve this, first of all, we have to open the bracket. When we open the bracket, times 4 plus 4 times minus 2 is going to give us manganese minus 1. The minus 1 we have here, minus 8. Okay, 4 times 2 is what? 8. Plus times minus is what? Minus. Okay, so we're having minus 8 equal to 0. What are we going to do here? We collect like terms. We bring manganese to this side and we bring 0 to this side. So because manganese has crossed equal sign, it becomes minus mn. Because 0 crosses equal to sign 2, it becomes minus 0. So minus 0 plus 1, this one we have here, minus 8 equal to minus mn. Okay, and when we solve this, we are going to do minus 0 plus 1. What is it going to give us? Minus 0 plus 1 is going to give us 1. Plus 1 minus 8 is going to give us minus 7. We are going to get minus 7 equal to minus mn, which is going to give us, when we bring this here, cross the equal sign, it becomes mn or plus mn. And when minus 7 crosses the equal sign to this side, it becomes plus 7. And it's going to give us mn equal to plus 7. So we already got the oxidation number of manganese in this compound, potassium MnO4. This compound can be named as what? Potassium tetraoxomanganate 7. The oxidation number of manganese here is plus 7. Now that we have understood how to calculate oxidation number, let's move straight to the Jamb repeated question 4. The question reads, what is the oxidation number of sulfur in H2SO4? A minus 2, B 0, C plus 4, D 6. So let's find out. What was given to us here? Hydrogen was given to us. The charge of hydrogen is plus 1. The next here is sulfur. And since we are looking for sulfur, we are going to represent it as S. Okay, let it be S. And the final one we have here is oxygen. It's going with the minus 2 charge. That's the charge of oxygen. Sum of all oxidation equals 0. So we are going to put them in bracket to avoid confusion. Plus 1 here times 2, which is the oxidation number of hydrogen here. Look at it here. Plus 1 times 2, bracket close. Plus the next is what? Sulfur. Sulfur, which is S, then bracket open to avoid confusion. Since we are having both a charge and an oxidation number, we are going to put it minus 2 is the charge times the oxidation number of oxygen, which is 4 plus 4, bracket close, equal to 0. When we open the brackets, it's going to give us 2 times 1 is 2, minus 2 times 4 is going to give us minus 8. Okay, so we are having 2 plus S minus 8 equal to 0. So when we collect like terms, it's going to give us minus 0 plus 2 plus 8 equal to minus S. Remember, we bring S to this side and bring 0 to this side. When they cross equal sign, their sign changes to the opposite sign. So when we solve this, minus 0 plus 2 will give us what? 2. So we are going to have what here now? Plus 2 plus 8. Plus times plus is what? Minus. We will now have plus 2 minus 8. Plus 2 minus 8 will give us minus 6 equal to minus S. So we have here minus 6 equal to minus S. S now is equal to plus 6 when both of them are exchanged. When we exchange their position and they cross equal sign. So let's head back to the Jamb repeated question. The option we have here, option A is minus 2, option B is 0, option C is plus 4, option D is plus 6. A is not the correct option. B, which is 0, is not the correct option. C, which is plus 4, is not the correct option. All for your correct option, which is D, plus 6. Jamb repeated question 5. The question reads, the IUPAC nomenclature of the complex salts, this complex salt you're having here, potassium 4, iron cyanide 6, is what? What is the IUPAC nomenclature? What is the name of this compound we are seeing here? A. Potassium hexacyanoferrite 2. B. Potassium hexacyanoferrite 3. C. Potassium hexacyanoferrite 4. D. Potassium nomenclature of the complex K4Fe bracket Cn6 is what? D. Potassium hexacyanoferrite 5 is not the correct option. C. Potassium hexacyanoferrite 4 is not the correct option. B. Potassium hexacyanoferrite 3 is not the correct option. Or for your correct option, A, which is potassium hexacyanoferrite 2. This is the correct option. Potassium hexacyanoferrite 2 is the correct option. Thank you so much for taking this lecture, and I hope you made notes for your subsequent revision. Congratulations on earning a free mark in Jamb UTME 2026. I believe that you must have learned 1 or 2 things that is going to be beneficial to you in your Jamb UTME 2026. Do not forget to subscribe and follow for more at Nkwado Augustine across all social media platforms. Do you have any question or knowledge gap? Drop your question in the comment section. Drop your suggestion in the comment section. I am going to do justice to your questions and suggestions as soon as I come across them. At this point, I'm